Nvidia's CES 2025 keynote was a historic event. One of those keynotes that, unless Jensen lied about some of these technologies or left out some very important details, we'll look back on and say this was the moment the world changed. From unbelievable next-generation graphic cards to robotics, self-driving cars, generative AI, and finally, perhaps the last piece of the puzzle to achieve true AGI. To understand how big of a keynote this was, consider that the least important and the first announcement was the next generation of Nvidia graphic cards called RTX Blackwell. This is a real-time footage rendered by an RTX Blackwell. Ultra-realistic lighting and shadows. Super accurate textures and materials. And all of it in 140 plus FPS. Every single pixel is ray traced. Ray tracing is a usually compute-intensive method to simulate lighting using millions of artificial rays. How is this possible in real time? Here is the summary.
There are two fundamental things that we did. We used, of course, programmable shading and ray traced acceleration to produce incredibly beautiful pixels. And so the neural network that's running on the GPU can infer and predict the pixels that we did not render. Not only can we do that, it's called DLSS, the latest generation of DLSS also generates beyond frames. It can predict the future, generating 3 additional frames for every frame that we calculate. It is an absolute miracle that we can computationally using programmable shaders and our ray tracing engine, to compute 2 million pixels and have AI predict all of the other 33. And as a result, we're able to render at incredibly high performance because AI does a lot less computation. It takes, of course, an enormous amount of training to produce that, but once you train it, the generation is extremely efficient.
How much is the RTX Blackwell graphic card? Condolences to all the people who bought RTX 4090 last year. RTX 5070 offers 4090 performance at $549, and RTX 5090 offers twice as much power as 4090 at $2,000. And here is a summary of the insane specs for the new Blackwell graphics cards.
92 billion transistors, 4,000 TOPS, 4 petaflops of AI, 3 times higher than the last generation Ada. And we need all of it to generate those pixels that I showed you.
There is also a laptop version.
Graphics card here, Blackwell, we're going to shrink it and put it in there. Does that make any sense?
Now I want to jump right into the most important announcement of the night. The new Nvidia model that, if true, is going to change the trajectory of the world forever. This new foundation model from Nvidia has been the missing piece of the puzzle for all 3 major categories of AI that we've been dreaming of. Fully functioning humanoid robots, fully self-driving cars, and true AGI. Let's start with AGI. Artificial General Intelligence is defined as a highly autonomous system that can outperform humans at most economically valuable work. Basically the sci-fi AI that can replace most knowledge workers at a lower cost. But there is a little secret that big AI labs have been keeping from the public. There is a huge debate among AI scientists about whether the current path of AI can lead to AGI. Respected experts like Yann LeCun, the chief AI scientist at Meta, argue that the current wave of AI will never achieve AGI. The fundamental disagreement lies in whether language contains enough knowledge of the world to train AGI. Yann LeCun argues we possess a higher level of understanding of the world in the realm of concepts, which we then compress into language to communicate. While language is a decent medium for exchanging information, it never fully conveys the sender's entire understanding. Even among humans who share many intuitions about the real world, language is often a source of misunderstanding. Also, animals, which don't rely on language, still demonstrate a level of intelligence. So obviously, biological intelligence doesn't rely entirely on language. The idea is that if we can train AI in a real-world environment, allowing it to develop its own understanding of the world alongside language, we might finally be able to crack AGI. Last night, Nvidia announced for the first time a foundation word model called Cosmos that helps AI understand the real world on its own, not relying on language alone. Why is this a significant achievement and why couldn't we do it before? Gathering enough high-quality data and recreating edge cases in the real world has always been practically impossible. So Cosmos generates realistic video footage with accurate physics. which can be fed to AI, enabling it to understand the real world, like the continuity of objects, gravity, or friction. Notice that we've understood these concepts long before we had words for them, and even intelligent animals grasp them. Cosmos has been trained on 20 million hours of real-world footage. But that's not enough, so they have grounded Cosmos in physics using a clever technique. Take a look.
Omniverse is a physics grounded, not physically grounded, but physics grounded. It's algorithmic physics, principled physics simulation grounded system. It's a simulator. When you connect that to Cosmos, it provides the grounding, the ground truth that can control and to condition the Osmos generation. As a result, what comes out of Osmos is grounded on truth. This is exactly the same idea as connecting a large language model to a RAG, to a retrieval augmented generation system. You want to ground the AI generation on ground truth. And so the combination of the two gives you a physically simulated, a physically grounded multiverse generator. And the application, the use cases are really quite exciting.
This is not a video generator like Sora or Veo, which are mostly for entertainment. This is a synthetic data generator that encapsulates real-world scenarios and creates numerous edge cases. While Jensen presented Cosmos as a near-perfect word model, as a first-generation product, it surely has limitations and flaws that will be uncovered in practice. This word model is also crucial for developing humanoid robots and autonomous vehicles, which can handle edge cases generated by Cosmos much more effectively. This doesn't replace real-world data gathering, but amplifies its impact by synthesizing more adjacent scenarios. Another incredibly powerful use case is simulating factories and warehouses. Gathering metrics and optimizing for higher efficiency is incredibly challenging for large factories. But now with Cosmos, factories can build a digital twin that simulates every important metric, which they can then optimize. Cosmos can also generate future scenarios and recommend actions that are most likely to improve key performance indicators. This one model, if it is actually as powerful as they claim, could lead to digital intelligence, next-level robotics, more efficient factories, and fully autonomous vehicles. When we look back on this keynote in the years to come, we may very well consider it the day Nvidia fundamentally changed the trajectory of AI and technology as we know it. It's open licensed, so any small or large company can use it to accelerate progress. Besides Cosmos, there were some other interesting announcements. Jensen recapped the Blackwell data center chip and how it is now in full production. Here are the insane specs for Grace Blackwell.
Here's the amazing thing. The memory bandwidth is 1.2 petabytes per second. That's basically the entire internet traffic that's happening right now. The entire world's internet traffic is being processed across these chips, okay? And we have 130 trillion transistors in total, 2,592 CPU cores, whole bunch of networking.
Then they announced the Llama Nemotron foundational language models. Here is how Jensen described these models and their capabilities.
Llama 3.1 is a complete phenomenon. The download of Llama 3.1 from Meta, 650,000 times, something like that. It has been derived and turned into other models, about 60,000 other different models. It is singularly the reason why just about every single enterprise and every single industry has been activated to start working on AI. Well, the thing that we did was we realized that the Llama models really could be better fine-tuned for enterprise use. And so we fine-tune them using our expertise and our capabilities, and we turn them into the Llama Nemotron suite of open models. There are small ones that interact in very, very fast response time, extremely small. They're what we call super Llama Nemotron supers. They're basically your mainstream versions of your models. Or your ultra model. The ultra model could be used to be a teacher model for a whole bunch of other models. It could be a reward model, evaluator, a judge for other models to create answers and decide whether it's a good answer or not, basically give feedback to other models. It could be distilled in a lot of different ways. Basically, a teacher model, a knowledge distillation model. very large, very capable. And so all of this is now available online.
Finally, they reveal a new approach to image generation with far more control for artists. You start by laying out 3D assets, then use the image generator to build a scene based on the rough layout. You can then modify objects, change camera angles, and generate more variations, or ask for specific looks. These images look fantastic, and there were other announcements, like a new desktop computer designed for AI workloads. But I think we've covered the highlights pretty well. Most importantly, the announcement of Cosmos, the first and only foundation world model. If you enjoyed the video, let YouTube know by clicking the like button. My name is Puriya, and I see you in the next one.